Hey guys, so today we are going to do chapter 2, section 1, over the trig functions of acute angled triangles. The chapters in this trig class are pretty short, and so we move through the chapters relatively quickly. And so we're going to go ahead and keep on moving and hit chapter 2 today. I have some drawings up here in the notes, and I'm screen sharing those with you of some pretty general triangles. I have one of them, the first one that's on the left-hand side over here that has the green angle drawn over it. This is one that's shown on the Cartesian coordinate system, and so that allows you to see the x, the y, and the r, which is how your book and how we've been talking about like our sine, cosine, tangent, and all that kind of stuff. And then next to it, I have drawn pretty much the exact same triangle. I've just drawn the triangle off of the Cartesian coordinate system. It's all labeled exactly the same. You have A, B, and C. You have theta down in the bottom left-hand corner of your triangle. But with this one, I have labeled it with the hypotenuse, the adjacent, and the opposite, because that's in terms of your theta. Where your theta is located determines what is the opposite and the adjacent in those triangles. But 2.1 is where your book finally starts talking about angles in terms of the adjacent, opposite, and hypotenuse, which is the SOHCAHTOA that I've actually already mentioned in the previous classes. So this is kind of just a reminder. This is a really good set of little notes right here where it shows you the relationship of the x, the y, and the r versus the adjacent, hypotenuse, and opposite sides of the triangle. And so like sine theta was y over r if you're on your Cartesian coordinate system. That's the same thing as your opposite over your hypotenuse. Remember, sine is the inverse of cosecant, and so we just flip those values on their heads and we have the cosecant values. Cosine theta was x over r over here on our Cartesian coordinate system. That's the same thing as adjacent over hypotenuse. Again, secant is the inverse of cosine, so we just flip those values. And then tangent was y over x if we are on our Cartesian coordinate system, which is the opposite over the adjacent, and cotangent, we flip those values. So this is a great reference tool. I've mentioned maybe having, like a page of your notes that is just like a quick reference sheet. This is all really good information to have on that quick reference sheet. And remember that since this is a virtual or recorded lecture, that if you would like to pause it and copy that stuff down, you certainly may, or you can also pull up my notes or print my notes off separately. Because obviously I can move through these a little bit quicker being virtual or online. Like with this recorded lecture. Down there beneath that, I did include the SOHCAHTOA, which I've already addressed in a previous lecture, but that's just a mnemonic to help you memorize what sides of the triangle are connected with the various trig functions. So the big S stands for sine, and that means opposite over hypotenuse. The big C is cosine, which is adjacent over hypotenuse, and the T for TOA is tangent with opposite over adjacent. And then obviously you could do their inverses with their inverse functions. So those are there. And then we do an example. I'm not going to work this example out. I will talk you through it. I don't think there's really a lot to show, like to be gained by actually watching me write down these values. So we're going to find sine, cosine, and tangent of theta for the following triangle, and they give you the triangle. They label the theta. They give you 24 on the bottom side, 7 on the right, and 25 on the hypotenuse. And so the sine theta is the opposite over the hypotenuse. So opposite of theta would be 7 over the hypotenuse is 25. 7 and 25 have nothing in common, so there's nothing to simplify. That is the end of it. Cosine theta is adjacent over hypotenuse. Adjacent is the one that's next to, but not the hypotenuse. So next to theta is 24 and the hypotenuse is 25. And then tangent theta is opposite over adjacent. So that will be opposite, which is 7 over the 24, which is adjacent. That's all you have to do for these problems. Don't make them difficult. Don't give decimals or anything like that. So I did want to flip over to our textbook. Remember on the My Math Lab site, you have access to the digital textbook, and there's this really neat, I think the book does a good job of making this connection of what exactly a cofunction is, in reference to like this triangle right here. So it gives you like this super generic right triangle that is acute, which means angles B and angles A are both acute angles. And then you can see that like the side opposite of angle A is lowercase a, and the side opposite of angle B is lowercase b, and the side opposite of angle C is lowercase c. So here's what's important to note, and what I think the book did a good job of kind of pointing out, is if I look at sine of A, so that's angle A, so sine of angle A, which is down here, sine is opposite, so A over hypotenuse, which is C. Okay, do we see that? Sine of A is A over C. But what if we talked about the cosine for a moment of B? Like usually we draw our sine or our thetas down there in the bottom corner, but theta could be in any of these two corners that aren't the right angle. So what if theta was up here in angle B and we talked about the cosine? So the cosine of B would be adjacent, which is A, over the hypotenuse, which is C. So notice that sine A equals A over C, which is the same thing as cosine B. And if we continue to look at these like different angles and their relationships, the tangent of A is A over B, but that's also the cotangent of B. And the secant of A is C over B, but that's the cosecant of B. So there's these different correlations that are being made where, depending on which angle of the triangle you're looking at, you could actually deduce some information about the other angle. And what happens here is that there's actually a relationship that's found. And here's the information. It says in any right triangle, the sum of the two acute angles is 90 degrees. So that means angle A and angle B have to equal 90 degrees. They're complementary. That's true because all of your inside angles have to equal 180 degrees. And if 90 degrees is taken up over here by the right angle, then you have 90 degrees left to go between those other two angles. So those other two angles are always going to be complementary. And if those two angles are complementary, then we know that sine A is the same thing as cosine B. And so here's another way of writing that. We can say sine of A is the same thing as cosine of 90 degrees minus A. What we did here in the blue, you can see they substituted in 90 degrees minus A. That's because A plus B equals 90 degrees. So we're doing a substitution. And the reason why is because then we have this relationship between sine of A and cosine of A. And this is going to be our cofunctions. Okay. This is a cofunction pair. And there's since it says pair and we have 6 trigonometric functions, we're going to have 3 sets of pairs. So sine and cosine get paired up, tangent and cotangent get paired up, and then secant and cosecant get paired up. So in my notes, I wrote out the same table, but because I wasn't planning on pulling up the notes if we were doing this lecture live in class. So here's the information. In my notes, it says cofunction identities. These are some really good, helpful identities that will help you to solve a lot of problems. It is helpful if you memorize them. So you definitely want to get to where you're comfortable with it. But it says for any theta less than 90 degrees, so we're talking about this whole section is acute triangles. And so these angles are acute or less than 90 degrees. We have sine theta is the same thing as cosine of 90 degrees minus theta. The flip of that is that cosine of theta is the same thing as sine of 90 degrees minus theta. And we have that correlation for secant and cosecant. We have that same correlation then for tangent and cotangent. And that's all based on what I just showed you with that generic triangle in the textbook. It says cofunction values of complementary angles are equal. So that's what that means. Obviously, you're going to want to write all that down, so feel free to pause. But we are going to do some examples next. Okay, so let's get into those examples. I went ahead and wrote those co-function pairings up here at the top of my page, just because I can't screen share when I show you my paper down here. So those are up there for us to reference as we move through these problems. This first example says to write these trigonometric functions in terms of their co-function. So here we have cosine of 52. So if we are dealing with cosine, then we need to go up here and say, well, cosine theta is the same thing as sine of 90 degrees minus that theta. So cosine of 52 degrees is the same thing as saying sine of 90 degrees minus those 52 degrees, which is the same thing as saying sine of 38 degrees. So here's what's really cool about this, is that if you look, 52 and 38, those are complementary angles. And the sine and cosines are our co-function pairing. So this is how this is working. Cosine of 52 is the same thing as saying sine of 38. Same thing with tangent of 71 theta. Its pairing is cotangent. So we're going to have cotangent of 90 degrees minus 71 degrees, which is cotangent of 19 degrees. Now, do you have to show this middle step in here? No. You may get to where you're like, okay, so I just change to my pairing, and then I subtract this value, the 71 from 90, and that gives me my 19. That's exactly what we're doing. I'm showing you this middle step because actually that's going to help you to get these co-functions pairings kind of stuck in your brain. So secant of 24, well, secant's co-pairing is cosecant, and that'll be 90 degrees minus 24 degrees. So that's cosecant. Just notice a typo in my notes. That'll be cosecant of 66 degrees. So in my notes, I accidentally wrote secant here again instead of cosecant. So just know that that is a typo on my part. But there we wrote these various trig functions in terms of their co-functions. So now let's look at this problem. It says find one solution. Assume that all the angles are less than 90 degrees. So again, they're telling us that all of our angles are going to be acute. And what we know is we know that cosine of theta plus 4 degrees equals sine of 3 times theta plus 2 degrees. So what we have here is we do have cosine equals sine, okay? And if we're thinking about our co-functions, what do we know about co-functions? What do we know about the angles of co-functions? The angles of co-functions are complementary. Angles of co-functions are complementary. That means they add up to 90 degrees. That means if we took the angle here and we added the angle here, we should get 90 degrees. And that will also help us to determine what theta is, because we don't know. So we have theta plus 4 degrees plus 3 times theta plus 2 degrees has to equal 90 degrees, because these are co-functions. Cosine is the co-function of sine. So now we solve it just like we would any algebraic equation where theta is just our variable. It's like our x. And so we have theta plus 3 theta is 4 theta. 4 degrees plus 2 degrees is 6 degrees equals 90 degrees. Subtract that 6 over. You have 4 theta equals 84 degrees. Divide by 4, and we find that theta is 21 degrees. So we were able to use our co-function identities to set up an equation to solve for our theta. We're going to do the exact same process for tangent of 2 theta minus 18 degrees equals cotangent of theta plus 18 degrees. Tangent and cotangent are cofunctions. Let me slide this up a little bit. So we can do the exact same process. Cofunctions are complementary, so we can take 2 theta minus 18 degrees plus theta plus 18 degrees equals 90 degrees. Well, these percentages, or these degrees, are going to cancel, leaving me with 3 theta equals 90 degrees. And so theta equals 30. And that's how we use our cofunctions in order to find our thetas. Now, the rest of our notes are actually, there's a lot of just good reference notes, but we're going to kind of do them or discover them in terms of working a problem. There's some very special relationships with some of our acute triangles. One of those relationships is our 30, 60, 90 acute triangle. So notice 90 is one of them. That's because it's a right triangle. And then we have an angle that's 30 degrees and an angle that's 60 degrees. And we have this labeled already with our side lengths of 1, 2, and the square root of 3. That is just the information that they give us. And this is actually in terms of when we approach the unit circle in a couple sections, we have it equal right here. This 1 is equal to the distance of the radius outward. So anyways, this is the triangle they give us for 30, 60, 90. And then they ask us to find the 6 trigonometric functions. That's of 30 degrees, and they ask us to find the 6 trigonometric functions of the 60 degrees, because our sine of 30 degrees is not going to be the sine of our 60 degrees. They're going to be different. Yes, they're both opposite over hypotenuse, but if I'm talking about 30 degrees, then opposite is 1 and hypotenuse is 1/2, or excuse me, 2. But if I'm doing the sine of 60 degrees, then the opposite is the square root of 3 over 2. I'm not going to keep jumping back and forth between 60 and 30. I just wanted you to see that they are different. It really does matter which of the angles you are talking about and referencing. And so we're just going to go through and we're going to fill out this table a little bit. We have cosine of 30. That is going to be adjacent over hypotenuse. We have tangent, which is TOA, which is opposite over adjacent. So that's 1 over radical 3. Again, we do have to rationalize that to where we get radical 3 over 3. Cosecant is just going to be the flip of sine. 2 over 1, which is 2. And secant is the flip of cosine. 2, or the inverse, I guess, is the more mathematical term. Probably should use that since I'm your professor. Should give me 2/3 over 3, or 2 square roots of 3 over 3. Sorry, I can't make my camera go any wider. And then cotangent is going to be the flip of tangent. But again, I'm going to just go right here to this 1 over square roots of 3, not over here. That way I don't have to rationalize my denominator again, because that'll give me the square root of 3 over 1, which is just the square root of 3. So there I found all of my trigonometric functions for my 30-degree angle. Now I do the same thing for my 60 degrees. So I already found my sine. Cosine of 60, cosine is going to be adjacent over hypotenuse. Now, I kind of want to show something here. Even though I noted it right here, I kind of want to point it out right now. Notice that I just found cosine of 60 as 1/2. And sine of 30 was also 1/2. Do you see how those are the same thing? But look, those are cofunctions, and their angles add up to 90 degrees. And when that happens, they're the same thing. Do we see this? The same thing happened here. For sine of 60 is the same thing as cosine of 30. Do you see that interaction and that relationship that's going on? So hopefully we could actually figure out what our tangent of 60 is based on actually what like our cotangent of 30 was. You see that? We don't even have to really compute it If we know what the cotangents, if we know our 6 trig functions up here, we have the relationships based on the cofunctions to draw those answers out. Now, could you just say, well, secant is the flip of this? Absolutely. And could you just say, well, cosine is adjacent over hypotenuse? You certainly may. All I'm trying to show you, though, is that there are these relationships that even make it a little bit quicker if you have those presented. And this is why we have 30, 60, 90 in the same section as our cofunctions, because they do help us to figure this stuff out. So cosecant is the flip of sine. So 2 square roots of 3 over 3. Again, this would correlate over to our secant of 30, which is right here. Secant of 60 then would correlate, hopefully you see it, to our cosecant of 30, which is 2. And then cotangent would correlate to the tangent of 30, which is the square root of 3 over 3. Cofunction values are complementary, so the angles are equal. And this is our 30, 60, 90 triangle. Super important triangle. You will continue to see it throughout the semester. The other important, all triangles are important, I guess. But the other, special triangle pairing comes from our 45, 45, 90 triangles. So this one's actually a acute right triangle that is an isosceles triangle, because what happens is we have two sides that have the measure of 1, and that's because our two inside angles have the same measure of 45 degrees. And so we don't have to do, like on the last one, we had to find all the trig functions of this angle and all the trig functions of this angle, but since these two angles are the same, we only have to do this process one time, and that's kind of nice. So sine of 45, that's going to be opposite over hypotenuse, 1 over square root of 2, and I think at this point you guys are getting pretty good at rationalizing your denominators. I don't have to show you the middle step, although I'm talking and then I'm going to write it the wrong way. So that becomes square root of 2 over 2. Cosine of 45 degrees is going to be adjacent over hypotenuse, which is 1 over square root of 2. So it's the exact same thing. Tangent is going to be opposite over adjacent, which is 1 over 1. And then we flip them. Cosecant is the flip of sine, so that'll give me square root of 2. Secant would give me the flip of cosine. Cotangent would give me the flip of tangent. So this information is super helpful and important. And I remember in my high school trigonometry class, all of this information was shoved kind of down our throats in one of those 60-minute tables tests, like where we had to have it memorized. And this is what the table looked like. And this is a great table to have as a reference table, where you would have your theta like this, and you'd have 30 degrees, 45 degrees, and 60 degrees. And then you would have your 6 trigonometric functions, where you have your sine, so I don't have to go down quite so far, your cosine, your tangent, cotangent, secant, and cosecant. Now, I've told you I will never make you do a 1-minute time test on anything, but this table is super important. And if you did memorize it, it would be so nice and helpful. So I'm just filling in the information that we got through our triangles above. Definitely something you'd want to reference. You could practice making this over and over again. Again, I will not test you on it. I will not say, let's take a minute time test and see who can fill this out correctly. But what it does is, as we move forward, it's going to help you solve different equations and come up with different values so much quicker if you have this memorized. Because what this is all like leading up to or culminating to is our unit circle. And in our unit circle, we're going to have all these different reference angles. We're going to have 30, 45, 60, 90, and then we're going to have all of those angles again in quadrant 2 and in quadrant 3 and in quadrant 4. And the only thing that changes isn't the values, it's just the negatives. And so if you have this general table kind of memorized or set up, then when I ask you to find what is the sine of 120, you're going to know what that is, because you're like, oh wait, that's 30 degrees into quadrant 2, and quadrant 2 means that sines are, you know, whatever they are, if they're positive or negative. Like, you're able to come up with that information without actually having to draw a triangle or draw the angle out itself. And so this table is a very, very good reference table to go ahead and get memorized.